Hello, Algebra 2A, and welcome back to another lesson. We are on lesson 34, graphing linear equations. Our goal today is to graph linear equations and then talk about transformations of a function. And we'll use a line to talk about our transformations. We'll start with our warm-up. The expression rise over run is the slope of a line. Number 2, what is the y-intercept of a line whose equation is y equals 2x plus 5? Well, this is in slope-intercept form. Y equals mx plus b, where b is our y-intercept. So our y-intercept is b equals 0. B equals 5. Or even better, we could actually write the coordinate. The coordinate to that point would be 0, 5. In part 3, we have an equation where we know one point on an ordered pair. So we know the y coordinates. So we could put 2 in for y, which gives us 6. And then do a little algebra. We'll get negative x equals negative 2. Divide both sides by negative 1, which is going to give us 2. So 2 is our missing coordinate. In example 1, we are looking at which graph represents a linear function. And above we have the definition of a linear function is a function with a constant rate of change, and the graph is a non-vertical line. So the word linear does mean line, so we are looking for lines. So in example A, we have a line, so that one is yes. In example B, we do not have a straight line. I should have clarified that line needs to be straight. We have a curved line, which means no, that is not linear. There's not a constant rate of change. We have changing rates as we go. In example 2, we are going to practice graphing our linear equations. And both equations are in standard form, so we are first going to change them back into slope-intercept form. To put a line in slope-intercept form, I'm going to solve for y. And the process is the same for changing a standard form into slope-intercept. We're first going to subtract our x term over. In this case, because it's a positive x, we'll use algebra, inverse operation. So 3y is going to equal negative x plus 12. Then we'll divide everything by the y term, which is 3. And we'll get y is equal to negative 1/3 x. 12 divided by 3 is 4. Now we're ready to graph. To graph, we always start with the y-intercept, which is 4. So I go to my y-axis, and I'll make a 4 right there. And then I'm going to go down 1/3. And once I start to see that line forming, I can go ahead and graph my straight line. Moving on to part B. Since I have a standard form again, I will use algebra to get this changed back into slope-intercept. So I'll first add the x term over, so I'll get 4y equals 3x minus 4. Then divide everything by 4. And we'll get our y alone. And 4 does not divide, but I could write that as a fraction, 3/4 x. And negative 4 divided by 4 is 1. Now I can go to my graph. I'll find where negative 1 is. And then I have a fractional slope like I did in the last problem. I'm going to rise 3, run 4. So I go up 1, 2, 3, 1, 2, 3, 4. And one more line just for good, or excuse me, one more point just for good measure is actually going to be right there. And I can start to form my line. So graphing standard form, I can take and rewrite my equation into slope-intercept and graph using the slope and the y-intercept. In example 3, we are going to practice graphing an equation that's in point slope, which I sometimes just abbreviate as PS. So point slope is going to be y minus y1 equals m x minus x1, where the y and the x are a point that's on the line, or excuse me, the y1 and the x1 are points that are on a line, and m represents the slope. So as I'm looking at this problem, I've got a slope of 2/3. And then x minus 1 means I have an x coordinate of 1. And then y plus 2 is really meaning y minus a negative 2. So you kind of think about it opposite. That's going to be a y coordinate of negative 2. So I'll head to my graph. I'll go 1, negative 2. There's going to be one of the points that's on the line because a point slope form, the x1 and y1 represent a point that's on that line. And then I'll use my slope of 2/3, rise 2, run 3, rise 2, run 3. And once I get a line forming, I can go ahead and construct my line. And there it is. So that'll conclude day 1. We're practicing graphing. You are now ready for your assignment practice. Thanks for joining, and we'll see you next time.